Assalamualaikum warahmatullahi wabarakatuh and greetings to all of the respective panel. I am Nor Zahirah binti Khairol Bong will presenting my video demonstration on my final year project entitled High Gain Sectorial Array Antenna at 28 GHz for 5G application. So let's proceed. First of all, the objective of my research is to design the sectorial array antenna with 10 dBi capability from point to multiple point communication, designing the sectorial array antenna to have a high gain which can reach 10 dB and with a return loss of not less than negative 10 dB is the limitation for this research. As recent monopole type base station antenna covered 360-degree coverage, the gain is low and may not cover suitable distance on base station because of having small wavelength, and the coverage may be short. To overcome the problem of the directional antenna, which only covers 60 degrees of coverage, a semi-hexagonal shape of directional antenna will be designed so it will cover 180 degrees of coverage. So in this research, we will focus on designing the best array antenna which best answered the main objective.
There are 4 designs that have been proposed in this research, which are: first, double array antenna with power divider; second, double head-shaped array antenna; third, 4x2 array antenna; and the last one, 4x4 array antenna. There are 3 main parameters that have been analyzed in this research, which are return loss, gain, and angle of peak main beam of radiation pattern to differentiate and observe the 4 design, and the best design which answered the main objective will be selected. This table shows the tabulated result for analysis on various design of antenna. So, let's start with the analysis. First, the discussion concentrated on the return loss of each antenna. The 4x2 array antenna showing the highest return loss with value of negative 19.57 dB, followed by 4x4 array antenna, double array antenna with power divider, and double head-shaped array antenna with the return loss of negative 18.39 dB, negative 6.52 dB, and negative 1.39 dB respectively. As mentioned on the previous results discussion above, an antenna need to have a high return loss for at least 10 dB because this parameter tested how much power the system receives at the input port is reflected back. Absently, no reflected power should be available and 100% of power should be delivered from the base station. Return loss below negative 10 dB means that at least 90% of the input power is supplied to the device and less than 10% of the reflected power is supplied. As designing a high-gain antenna is the main aim for this research, this analysis focused on appointing an antenna that capable to produce a high gain. From table shown, 4x4 array antenna possess the highest isotropic gain, which is 16.02 dB, far greater comparing to another antenna which are 8.48 dB, 8.36 dB, and 7.46 dB. A high gain antenna enables much of the transmitted power to be transmitted to the receiver, boosting the signal strength received. Furthermore, a high gain antenna absorbs more of the signal as it is transmitted, which again increases the signal power. Last but not least, radiation pattern is one of the essential parameters to be observed and measured in this research. Radiation pattern is not suitable to be simply determined by only having a good radiation pattern, but the angle of the peak main beam of the array antenna is the one that needs to be noted on. The peak of a radiation pattern's main beam implies a high level of field intensity, and around 70% of the radiated energy is found in the main beam area. A good radiation pattern defines as if the peak main beam of radiation pattern produced towards the 0 degree promise to give a more focused and high density of coverage for the transmission of signal for the base station during point to multiple point communication of 5G application. Referring to the comparison in the table shown, for time for array antenna producing and achieving to have the peak main beam angle of radiation pattern at 0 degree, while the second nearest to 0 degree angle is 25 degree, which is 4 times to array antenna. Therefore, as mentioned by the analysis and discussion before, this research concluded the 4 time for array antenna is the best design suited the objective and answering the expected outcome with negative 18 dB of written loss, which is the second highest written loss comparing to another two designs. Despite of not having the highest written loss as 4 times 2 array antenna, negative 18 dB is also considered as a good written loss which is suitable for the application of 5G. Besides, for time 4 array antenna transmitting the highest isotropic gain with 16.02 dB compared to another design. Finally, the angle of the peak main beam of radiation pattern of 4 times 4 array antenna design is the most focused as it located at 0 degree. It is significant to have an antenna with a good radiation pattern since it indicates the way the antenna distributes its energy in space. So, let me present the model which represents the transmission of signal from the base station to other users. For information, base station is function to transmit any communication signal from point to multiple point communication from base station to users. A good base station needs to produce more focus and high density of coverage for the transmission of signal for the base station for 5G application by having high gain, less written loss, and good transmission signal and coverage. This tower represented the base station which locating the 4 times 4 array antenna that will be arranged in semi-hexagonal shape which located at the base station. The reason of the implementation of this shape of design is as semi-hexagonal shape able to cover a wider coverage 180 degree while remain the high gain as the focus point of the radiation pattern for each of the array antenna is small. By arranging the array antenna into semi-hexagonal shape, each side of sector have its own focus point and the occurrence of interference can be avoided. Thus, the high gain of the antenna can be remained and the written loss also can be reduced. This is to ensure the good coverage of the transmission signal at 28 GHz from the base station for 5G application.
Based on all the parameters measured in this research, the importance of the research is first, it have a potential in leading antenna design for smart antenna concept used for 5G communication. Next, it able to prove hexagonal shaped antenna is favorite candidate for 5G smart antenna system. Last but not least is to implement best suitable design of antenna for 5G application. In the aspect of sustainability and environmental friendly, based on the Cisco report of Yearly Visual Network Index (VNI), there are quantitative proof which show explosion of data in wireless communication is true and will continue. It almost can be guaranteed that 5G will sustain into upcoming 10 years. Next, this project undergo by simulating using CST software first, which help to reduce the trial and error process on the real prototype, and only the optimum design will be taken and fabricated. Last but not least, this implementation of antenna is a very low power consumption which can ensure the less usage of power. This way can help us to well preserve the environment. In conclusion, during designing and selecting the best antenna design, some parameters have been chosen as the indicator such as isotropic gain, written loss, and also radiation pattern. This research concluded 4 times 4 array antenna design which replicates the intercon design is the best design suited and answered the objective by having high gain, less written loss, and a focus and better radiation pattern. With that, Thank you for your time and attention. Assalamualaikum warahmatullahi wabarakatuh.